Hassan. My student ID 2420100024 from section A, Math 16. I am honored to present this topic to our respected course teacher Rajakumar Darsa. Today my presentation is about periodic table tables, a fundamental concept in chemistry that helps us understand how elements behave. The periodic table is more than just an arrangement of elements. It reveals pattern in atomic structure and properties that helps periodic chemical behavior. Before we dive into specific terms, let's understand why they matter. The periodic table is arranged in a way that allows us to see how different element changes in their properties as we move across rows and columns. This tense helps scientists predict how elements react with each other, which elements are metal and non-metal, how elements bond to form compound. Now let's explore the key periodic terms one by one. Atomic radius refers to size of an atom, which depends on the number of electron shells and the nuclear charge. Across a period, atomic radius decreases. Why? Because as we move across period, the number of protons increases, pulling electrons closer to the nucleus, making the atom smaller. Down a group, atomic radius increases. Down a group, atomic radius increases. Why? More electron shells are added, increasing the size of the atom despite the increased nuclear charge. Thinking of it like a magnet. A strong magnet pulls object closer, just like a nucleus pulls electron inwards. Ionization energy. Ionization energy is the energy required to remove an electron from an atom. Across a period, ionization energy increases. Why? Atoms hold on to their electrons more tightly because of stronger nuclear charge. Down a group, ionization energy decreases. Why? The outermost electrons are farther from the nucleus and easy to remove. For example, alkyl metals like sodium lose electrons easily, making them highly reactive, while noble gases like neon have very high ionization energy because they don't want to lose electrons. Electronegativity. Electronegativity is an atom's ability to attract electrons when forming a bond. Across a period, electronegativity increases. Elements like fluorine have high electronegativity because they strongly attract electrons. Down a group, electronegativity decreases. Elements like cesium have low electronegativity because they don't attract electrons as strongly. A simple way to remember this is non-metals like oxygen and fluorine attracts electrons strongly, while metals like sodium and potassium do not. Electron affinity. Electron affinity refers to the amount of energy released when an atom gains an electron. Across a period, electron affinity increases. Non-metals want to gain electrons to complete their outer shell, so they release more energy. Down a group, electron affinity decreases. Larger atoms have weaker attraction for extra electrons, so they release less energy. For example, fluorine have a very high electron affinity, making it one of the most reactive non-metals, while metals like sodium have low electron affinity because they prefer to lose electrons. Metal versus non-metal. Metallic character. Metallic character decreases across a period, non-metals dominate. Increase down a group, metals become more reactive. Non-metallic characters increases across a period, decreases down a group. This is why metals like potassium are very reactive, while non-metals like chlorine are also reactive but in a different way, by gaining electrons. These are the summaries of my topics. Practical application and how these terms impact on chemical behavior. Understanding periodic terms helps periodic chemical reactivity, bonding behavior, and the properties of elements. These insights are invaluable for research, development and application in diverse fields, including medicine, material science and energy production.